What's up guys, this is Massey. Welcome to another video. In this video I want to show you some example regarding growth rate and population questions. The first example here, it says the population of a city was 185,000 on January 1st, 1989 and it was 295,000 on January 1st, 2005. If the growth of the city can be modeled as an exponential function, then find the average annual growth rate of this city. Express the nearest tenth of person. So I'm gonna say if we call population in P, population equals to P naught 1 plus x to the power of t. So P is current population or population in future. P naught is original population. X is the growth rate and t is time. So that's gonna be 295,000 equals to 185,000 times 1 plus x to the power of from 1989 to 2005. So that's gonna be 16 years. Now we need to solve it for x. How can we do that? We divide both sides by 185,000. $295 divided by 185 is gonna be 1.5946 equals to 1 plus x to the power of 16. Then I get log of both sides. Then I can say log 1 plus x equals to log 1.5946 divided by 16. 1.5946 divided by 16 is going to be 0.01266. So 1 plus x is going to be 10 to the power of, because the base is 10 here, 0.01266. So 10 to the power of 0.01266, which is going to be 1.0295. So x will be 1.0295 subtract 1, which is 0.0295. And that's going to make it as times 100, 2.9%. So that's going to be the growth rate. Now next example, it says an insect colony has a current population of 60 insects. Its population doubles every 3 days. What is the population after 20 days, and how long it takes until the population reaches 27,000. So when I write the formula, P equals to P naught 1 plus x to the power of t divided by a cycle. In this example we have cycle every 3 days, so we need to divide it by theta. So population, initial population was 60, and we need to estimate the population in future. So this is the initial, this is the final. 1 plus x, here it says doubles. It means that 100% more. So it means that 1 plus 1 to the power of t divided by 3. And t is supposed to be in terms of days, because these 3 days we have for one cycle. So p equals to 60 times 2 to the power of t divided by 3. Okay, so after 20 days, we have 60, 2 to the power of 20 divided by 3. $101.59366 times 60 is going to be 6,005.9.6, which rounds to 6096. So that's the answer for the first part. It means that this is going to be the new population after 20 days. On part B, it says how long will it take the population reaches 27,000. So we have 27,000 equals to 60, 2 to the power of t divided by 3. Now we need to find t in this case. We need to divide both sides by 60. So 27,000 divided by 60 equals to 2 to the power of t divided by 3. So 27,000 divided by 60 is going to be 450, 2 to the power of t over 3. So we take log of both sides. Then t over 3 is going to be log 450 divided by log 2. So log 450 divided by log 2 is going to be 8.8137. So t will be, this times 3, 26.4. So it means that after 26.4 days, the insect population is going to go from 60 to 27,000. Next example, a bacteria culture doubles every 15 minutes. How long will it take for a culture of 20 bacteria to grow to a population of 200,000? So again, P equals to P naught. Since it doubles is 1 plus 1, so 2 to the power of time divided by theta, because again we have a cycle here every 15 minutes. So theta is 15 minutes. So it was basically, we have P as well, 200,000 equals to 20 initial population, 2 to the power of t divided by 15 minutes. So in order to find t, we need to divide both sides by 20. So that's going to be 10,000. 2 to the power of t divided by 15. Then we need to take log of both sides. So t divided by 15 is going to be log 10,000 divided by log 2 is going to be log 10,000 is supposed to be 4 divided by log 2 is going to be 13.2877. So t will be 15 times 13.2877. That's going to give me 199.3 minutes. So it is going to be almost approximately 200 minutes in order to have 20 bacteria grow to 200,000 bacteria. So next example, it says if the starting population of 10 cats grows at 200% each year, how many will there be in 20 years? So we're going to say P equals to P naught 1 plus x to the power of t. Since this is every year, so it's d divided by 1 basically, which is just t. So P equals to 10 times, it doubled, so it's going to be 2 to the power of t. T is going to be 20 years. So it's going to be 10 times 2 to the power of 20 times 10 is going to be 104,85760, which is going to be 1,048,000. It is actually is going to be 10,485,760. And then if you want to find out in 50 years, how many will there be in 50 years, you're going to say P equals to 10, 2 to the power of 50. So that's going to be, it's going to be 1.125 times 10 to the power of 16. So it's going to be a lot. Now, next example, it says a population of 150 frogs increases at an annual rate of 19%. How many frogs will there be in 5 years? So P equals to P naught 1 plus x to the power of t divided by theta. Since it's annual, it's going to be divided by 1 or just t. So we have P equals to 150 1 plus 0.19, that's 19% to the power of 5 years. So that's going to be 1.19 to the power of 5 times 150. That's going to give me 357.95, or almost 358 frogs. That's how we find out the population in future. Then next example, it says a type of bacteria has a very high exponential growth rate of 75% every hour. If there are 100 bacteria, determine how many there will be in 10 hours and how many after 1 week. So it's going to be P equals to 100, 1 plus 0.75 to the power of 10 divided by 1, which is going to be 10. So that's going to be 100, 1.75 to the power of 10. (26938.94), or almost 265,939 bacteria. So now next one is 1 week, it means 7 days. 7 times 24, we have 168 hours, because 1 week is 7 days and each day 24 hours. So 100, 1.75 to the power of 168. It is going to be 6.767 times 10 to the power of 42. That's going to be a population after 1 week. In this example, it says the population of a city was 3 million in 1998 and is growing at the annual rate of 1.3%. If this growth continues, what will the approximate population of this city be in year 2025? So P equals to P naught 1 plus X to the power of T. So we need to find out the population in future. Initial population 3 million. I keep it as 3 million, 3. 1 plus 0.013 for 1.3% to the power of T. T is 2025, subtract 1998, that's going to be 27. So 1.013 to the power of 27 times 3, it is going to give me 4.25 million. So that's going to be the population in 2025. So now this example, it says if a population of rats was 20 in January and 35 in February, what's the percent growth of these rats? So we're going to say 35 equals to 20 times 1 plus X to the power of, if we consider monthly, January to February is going to be 1. So we have 1 plus X to be 35 divided by 20. That's going to be 1.75. So X will be 0.75. So it means that 75% growth rate in 1 month. So I can write it 75% monthly growth rate. Now in this example, it says if there are 120 bears in a forest this year and 137 in 2 years, what percentage or what percent is the percent growth of the bears? So it's going to be 137 equals to 120, 1 plus X to the power of 2. In order to solve X, I need to divide both sides by 120. 137 divided by 120 is going to be 1.1416 equals to 1 plus X to the power of 2. Then I find the log of both sides. Log of 1.1416 equals to 2 log 1 plus X. So log 1 plus X equals to log 1.1416 divided by 2. That's going to be 0.028756. So 1 plus x is going to be 10 to the power of 0.028756. So it's going to be 1.068. So it means that x is 0.068 or 6.8% annual growth rate. So that's going to be the growth rate for number of bears. The last example of this kind, it says 3 years ago there were 760 goldfish in a pond, and this year there are 197. What is the percent growth of this population? So it is now 197. It was 760 before, so 1 plus x to the power of 3. So we divide both sides by 760. So 197 divided by 760 is going to be 0.2592. Then you do log of both sides. So log 1 plus x is log 0.2592 divided by 3. That's going to be negative 0.919545. So 1 plus x is going to be 10 to the power of negative 0.19545. It's going to be 0.6376. So x will be 0.6376 subtract 1. It's going to be negative 0.3624 or 36.24. And since it's negative, we are dealing with decay. That's decay percentage. That's the decay percentage for the population of goldfish in this pond. So this is the final question. I hope you enjoyed this video. Please leave me a comment if you have any question. Please don't forget to subscribe to this channel. You can have access to many other videos regarding half-life, population, and other topics in math, chemistry, and physics. I will leave some related videos and playlists in the description in case you need extra practice questions. Thank you for watching and have a great day.